Hi, folks. Welcome back to 4.6 part 4. And so in this video, we're going to do a quick summary of what we've talked about for exponential equations. And then we're going to go ahead and dive into logarithmic equations. All right. So let's start with this diagram at the top with our exponential form. All right. So anytime we have b to the x equals y, right? Or really, the question is, the thing we want to find is in the exponent, okay? So if the thing we want to find is in the exponent, all right, then here's where I feel like a salesperson, we can do this in 3 easy steps, right? It turns out that every time if we have an exponential equation, we go through these 3 steps, then we'll be able to get to that right answer, okay? Sometimes it might be longer, like if we have the same base, we might not want to use this, but we could use it, it would just take longer, okay? So first thing we want to do, we want to get our exponential all by itself, which means we want to have something that looks like this, okay? Then we're going to rewrite it in log form. So let me just add in here what that would be. Log base b of y equals x. All right. And then we're going to go ahead and solve for the thing that we're looking for. All right. So anytime we have an exponential, unless it has the same base, we probably want to use these 3 steps. The good news is that it's very similar for the log form. Okay. If we end up with something with logs, then in 3 easy steps, we can find the answer, right? We can isolate the log, we can rewrite it in exponential form, and we can solve for the unknown, all right? So a nice handy slide in there for you to maybe use that to help guide your equation solving, because I know there's so many different types, it might be hard to keep them all straight. All right. So in this video, we're going to focus on solving log equations. We're going to take a look at when bases are equal, and then we'll start to move into some of them where the bases are not equal. All right. So let's start with the cases when the bases are equal. And if we think back to the very first question we had for the log equations, we had something like this: 3 to the x equals 3 to the 7. And I think it made sense for all of us that x then has to be equal to 7, right? As long as the bases are the same. So it turns out we can do the same thing with logs. I have a natural log on this side and a natural log on this side, and only one natural log, okay? Then I can say this, right? Which basically is saying this thing that I'm logging has to be equal to the other thing that I'm logging. All right. So if I look at this particular question, I might think, ooh, a quadratic. And we just talked about quadratics in the previous video, right? A good strategy, move everything to one side, set it equal to 0, solve for x. So x squared minus 2x minus 3 equals 0, right? I want to find a clever way to write, this negative 2x. So I'm going to do my factoring off to the side, negative 3 and negative 2. So negative 3 times a positive 1 will give me negative 3, but negative 3 plus 1 will give me negative 2. So instead of writing x squared minus 2x minus 3, I can write x squared minus 3x plus 1x minus 3 equals 0. And now I have cleverly split that middle term. That allows me to clump the first 2 terms, the second 2 terms, and then look for the greatest common factor in each one. X times x minus 3 plus 1 times x minus 3, which is x plus 1 times x minus 3 equals 0. All right, let's finish this off. X plus 1 equals 0, and x minus 3 equals 0. So x equals -1 or x equals 3. But we should plug them both back in, make sure that we get the same thing on both sides of the equation. So let's check our answer. We're going to try first with the -1. Natural log of -1 squared is 1 equals natural log of 2 times -1 plus 3 is 1. Okay, so that one works out. This I can box off and say is an answer. Let's try with the 3. Natural log of 3 squared is 9 equals natural log of 2 times 3 is 6 plus 3 is 9. Oh, well, that's also equal. So this one also works, right? So in log equations, super important to check your answers, but I've got 2, they both work. So x can equal -1 or 3. All right, let's try example 11. All right, so for example 11, right, we also have the same base. We've got log base 13, and there's only one log on either side. That means 5x minus 2 is equal to 8 minus 5x. So let's write that out. 5x minus 2 equals 8 minus 5x. I'm going to add 2 to both sides and add 5x to both sides. I get 10x equals 10. I get x equals 1. Right? Now, before I fully say, yes, this is my answer, let's plug it back in and just make sure it works. All right, log base 13, 5 minus 2, and then log base 13 of 8 minus 5. Well, both sides give me log base 13 of 3. So indeed, our answer checks out, all right? So when the bases are the same, life could definitely be a little bit easier, all right? But let's try seeing what happens when the base is not the same, right? And in particular, we're going to practice these few steps. Isolate the log, rewrite it in exponential form, and solve for the unknown, okay? All right, let's take a look at example 12. I look and I see I've got the log all by itself. And so all I need to do is start with step 2, rewrite it in exponential form. Here's my base. Here's my power. And here is the thing I don't know. 3 to the 4th equals 9x plus 2. Now, I'm going to ask us not to simplify this. I'm going to ask us to write it in exact form. That means I don't want us to turn 3 to the 4th into a number. We can just actually leave it like that, okay? Some of these powers are going to get really big. They're actually too big for our calculator to handle. So we're going to keep them as like powers if we can, okay? So to get x all by itself, I'm going to subtract 2 and then divide by 9. So 3 to the 4th minus 2 equals 9x, and then x equals 3 to the 4th minus 2 over 9. Right? And I'll leave it up to you. Plug this back in, see if it works. All right. Now, let's take a look at 13 while it's on the page. I notice that the 2 is in the same place as the 4. Great. The 5x minus 11 is in the same place as the 9x plus 2, but I don't see anything in the same place as the 3. But there's got to be something here, right? There's got to be something there. And so this is a good chance for us to remember that, well, when we don't write the base, It is a common log, which really means that base is 10. So let's rewrite it now in our base to a power equals the thing we want, okay? So 10 to the 2 equals 5x minus 11, right? 5x minus 11, power of 2, base of 10, right? So I'm going to add 11. I'm going to divide by 5, all right? So 10 squared minus 11, plus 11 is 5x, and then x equals 10 squared plus 11 over 5. Perfectly fine answer. Okay, again, I'll leave that to you to plug it back in and see if it works. All right, let's do one last example here. And this time we are going to have to isolate our log, right? In other words, we want to get this all by itself before we try and rewrite anything in exponential form. So I'm going to subtract 4 from both sides first, and then I'm going to divide by 3. All right, so 3 natural log x minus 3 equals 1. Natural log of x minus 3 equals 1/3. Okay, now I would say we're almost ready to write it in exponential form. And I say almost because, again, I don't see a base here, right? I don't see a number down here. When I know this is the power it'll be raised to, and I know this is my unknown. So in order to see that power, it might be helpful if I write it like this, log base e instead of natural log. Now I have my unknown, the power that I'm raising it to, and that all-important base. My base is e. So now I have e to the 1/3 equals x minus 3. Only thing I need to do to get x by itself is to add 3 to both sides. All right, and I'll leave that for you to plug into your equation and see if that works. But let's get all 3 of these on one page, all right? So these are some pretty classic log equations where we just have to isolate that log and then rewrite it in exponential form, all right? Come on back for the 5th video where we're going to take a look at some questions that actually involve using 4.5 stuff. See you there.